What's up, math scholars and math haters? This is Mr. W. We are going to start a new unit of discrete math in the set of videos that I'm doing. And this one is going to deal with statistical distributions. This is going to be the first video in that little series, and it will focus on the different types of distributions that you could see if you ever look at any kind of statistics problem that asks you to comment on the shape of a distribution. That's the big idea of this video. And we're going to go over 6 basic shapes. So I'll go ahead and just get started. The first one we call uniform. That's this one right up here. Now, as you can see, the bars in this histogram are pretty much flat, not exactly, but mostly, to the point that we can pretty easily say that the data is evenly spread out as much as we can. And I'll go ahead and draw the shape for each of these. It generally looks about like this, just a flat line. And if we're thinking about a characteristic of a uniform distribution, just the visual characteristic, we would call that mostly flat. I'm getting a couple of Princess Bride vibes from saying that, but this the uniform distribution we would say is mostly flat. Now over here, we have what are called the skewed distributions. Now I'll go ahead and start by drawing the shape of each of these. This is skewed right. We get a lot of data to the left and a little bit to the right. Skewed left is pretty much the opposite. A little bit of data to the left, a lot more to the right. You would generally, if you see a histogram with a whole bunch of bars, see them about take either one of these shapes. The memory trick that I like to use for skewed right and skewed left is that the skewed goes where there's less data. And I also like to think of this as, if you can see this coming to a point to the right of the graph or to the left of the graph, I like to think of that point as a skewer. And since we call these distributions skewed, then I'm going to go ahead and say that we're just looking at a skewer that points either right or left. And it's a bit counterintuitive because in a skewed right distribution you have more data to the left, in a skewed left distribution you have more data to the right. That's why I came up with the skewer trick. I think it helps to overcome that bit of counterintuitiveness about this idea. Alright, so next type of distribution we call bimodal. Now I do want to point out that if you were dealing with regular statistics, then a mode would just be a single number that showed up more often than any other number. In this kind of distribution, we think of a mode as basically a hump. And a bimodal distribution, we can see, ends up having 2 such humps. So that's the basic idea of a bimodal distribution. It just has 2 humps, and then you could see a related word is trimodal, which is going to have 3 humps, as you could probably guess from the prefix tri. Next, we have the asymmetrical distribution, and this one I'm not even going to bother drawing the shape for, because the basic idea of an asymmetrical distribution is not just that there's no symmetry like the name would imply, but there's not really any kind of pattern that we can easily work with. That is an asymmetrical distribution. Over here, we have the bell curve. Now, we will get to this in future videos. It is also known as the normal distribution, or the Gaussian distribution. You'll usually hear normal distribution if you're in school. But I think you can see that this distribution, if I draw that outline in purple there, it looks like what you typically think of when you think of a bell curve. I just started by drawing it with bars instead of anything else. And with a bell curve, essentially you just have one very large hump in the middle of your data. That's the basic idea of a bell curve. That's the basic idea of those 6 distributions. Now I did also want to touch on 2 other types of graphs that could be used to show a kind of distribution. First is called a frequency polygon. This starts from a histogram, starts from the typical histogram or bar graph that you would see. But what I've done is I've taken that asymmetrical distribution and I have just drawn a green dot in the middle of the top of each bar and in the left and right corners. And all I'm going to do in order to see how this distribution goes is I'm going to connect the dots. And using this, I think we can see that this holds about the same shape as this one. I think the point of a frequency polygon is to try to actually see some of that change between the frequencies of your different bars, just to look at it in a bit of a different way. The other type of graph that we could see and get a data distribution from is a stem plot, also known as a stem and leaf plot. So essentially, this starts with the idea that our tens are in the left column, and every data point is represented by their ones digit in the right column, but still with the same row as their tens digit. So this would be the number 12. We have 23 and 23, 31, 36, 39, and then 40, 43, and then two 48s. So that's how we would take each of these data points and put them in a stem plot. Tens digits go on the left, ones digits go on the right. What this will actually let us do is if I turn this, it will actually let us both see the shape of our data and see the actual data points at the same time. So I think what you can see is that we have a pretty much a little bit skewed left distribution. We have a little bit of data on the left side and a lot of data over here on the right side. But I did just want to use this as an example to show how we can get a distribution shape from a stem plot and at the same time see our individual data points. So I personally find this relatively useful for this particular type of math.